colligative properties of solution in which is number third colligative properties, depression of freezing point. Clear? So before proceeding, we have need to discuss what is freezing point. So freezing point, the temperature in which vapor pressure of a liquid is equal to vapor pressure of solid. Clear? For example, the freezing point of water is 0 degree Celsius. Clear? This is the temperature in which formation of ice is started. Clear? So this is the freezing point of water. Clear? Now we have need to discuss depression in freezing point. Depression in freezing point. Clear? So this is the temperature difference between pure solvent and solution. This is depression of freezing point. Means depression of freezing point may be defined as the temperature difference between pure solvent and solution. Pure solvent have different freezing point while solution have different freezing point. Clear? So let's discuss by the help of graph. So dear students, plot a graph. This is x-axis, this is x-axis, this is y-axis. Clear? This is vapor pressure and this is temperature. Clear? This is 0, this is 10, this is 15, this is 20, this is 25. Clear? This is the vapor pressure 5, 10, 15, 20 and 25. Clear? So first plot a graph of pure solvent. So the pure solvent, for example, we plot a pure graph of pure solvent for what? Pure solvent. This is the graph. Suppose this is the graph for pure solvent. This is the graph for pure solvent. Clear? Now plot a graph of solution. We know the vapor pressure of solution. Vapor pressure of solution decreases by adding the non-volatile solute. Clear? So by after mixing in pure solvent the non-volatile solute, the graph obtained this one. Clear? This is graph for solution. This is graph for solution. So dear students, at same temperature, suppose this is 5 degree. Clear? And this is 5, 10, 15. Clear? Now consider the temperature at 5 degrees centigrade. At 5 degrees centigrade, the graph for pure solution, graph of solution is this one. At 5 degrees centigrade, the vapor pressure of solution is 5 Pascal atm. Clear? But for pure solvent, the temperature difference is this one. At 5 degrees, the vapor pressure of pure solvent is 12. Just we can say this is 12. Clear? So this is the difference of pure solvent and solution. Suppose this is the temperature T naught F, clear, and this is TF. So TF equals to freezing point of pure solvent. This is T naught F, clear, and the TF is freezing point of solution, clear. So come to the graph. This is the TF, which is temperature for solution, freezing temperature of solution, while this is T naught F, this is freezing point of pure solvent. The temperature, this is the difference. At 5 degrees centigrade, the vapor pressure of solution is 5 atm, while at 5 degrees centigrade, the pressure of pure solvent is near about 12 atm, clear. So this is the difference. 12 minus 5 equals to 7 degree. The difference is 7 degree. This is diffraction of freezing point of pure solvent between solution, clear. So let's consider the total difference. The total difference between pure solvent and solution. So this will be TF minus T naught F equals to delta TF. This is delta TF is depression of freezing point. This is depression of freezing point, clear. And we know very well that depression of freezing point delta TF is directly proportional to concentration of non-volatile solute. Non-volatile solute. Why non-volatile solute only? Because of in pure solvent, after mixing the non-volatile solute, the vapor pressure will be decreases. We have already discussed, clear. Non-volatile solute, concentration of non-volatile solute increasing, while depression of vapor pressure will be increased, clear. Okay, so let's discuss in terms of concentration. Delta TF is directly proportional to M molality, where M equals to molality. This is molality, not this is molality. Concentration terms molality. Okay, now we have already discussed the molality equals to number of moles of solute mass of solvent in kg. So it will become M equals to WA multiplied by MA multiplied by 1000 divided by WB in terms of gram. So it will become delta TF equals to KF multiplied by M, while KF is cryoscopic constant, clear. KF is cryoscopic constant. This is important for competition. KF is known as a cryoscopic constant. Cryoscopic constant, clear. Okay, so put the value of M. by the equation. So it will become delta TF equals to KF multiplied by WA multiplied by 1000 divided by MA multiplied by WB. This is the depression of freezing point. Clear? So the fourth colligative property is osmotic pressure. Before explain osmotic pressure, we have need to explain osmosis. What is osmosis? Clear? So osmosis may be defined as the movement of solvent particle oblique molecule. The movement of solvent particle oblique molecule to solution through semi permeable membrane. Clear? Movement of solvent molecule to solution through the semi-permeable membrane, or in other words, we can also explain movement of solvent molecule from high concentration to lower concentration. Lower concentration is known as a osmosis. Clear? Okay. Now, what is osmotic pressure? Osmotic pressure by applying the external pressure which can stop the movement of molecule from high concentration to lower concentration. Clear? Now, what is SPM? What is SPM? SPM is the semi-permeable membrane which have small pore and only allowed to molecule of solvent. Clear? So this is SPFL. The artificial SPM is K4FeCN6, copper potassium ferrocyanide, or CuFeCN6, Cu4. Clear? This is artificial SPM. So the osmotic pressure is directly proportional to M, means molarity. Clear? By removing the proportionally constant, just we can say pi is directly proportional to M. By removing the proportionally constant, we get pi is equal to R into molarity. Clear? Where molarity is equal to, but pi is also directly proportional to temperature. So we get pi is directly proportional to M into T. By removing proportionally constant, we get pi is equal to R into M into T. While while pi equals to C upon V, sorry, this is N upon V into R into T. What is N upon V? This is molarity. N upon V equals to molarity. Clear? Okay, so we get pi is equal to N divided by V into R into T. So this NV, N number of moles, V volume of solution in liter. So we get, this is concentration, so this is CRT. This is the osmotic pressure. Osmotic pressure, N upon V equals to concentration in terms of molarity, concentration in terms of molarity. Clear? So pi is equal to CRT. Pi is equal to CRT, but in case of solution, R is replaced by S, while R is equal to S, while this is rate constant. While in case of solution, it is solution constant. So R is rate constant in terms of gas, but S is equal to solution constants. So we can apply pi is equal to CST. This is want of factor. Clear? So please share, subscribe, and give me suggestion how I can improve. Thank you. Have a good day.